Time for all space nerds to hold our collective breath. Right now, we are moments away from what NASA scientists call the 7 minutes of terror. The reason is this. InSight, it's a Mars probe that left Earth last May and has traveled more than 300 million miles from home. Right now, InSight is in the process of landing on Mars. And so what you're seeing is this animation. The actual landing involves several complex steps. There's a reason NASA refers to this as 7 minutes of terror. Mars is already littered with failed probes, and we'll get into the complications of all of this and how huge the success will be. So with me, CNN aviation analyst Miles O'Brien. Miles is also a science correspondent for PBS NewsHour. CNN business correspondent Rachel Crane, who has covered space and is equally obsessed as I am. And Don Lincoln is a particle physicist and the author of Alien Universe, Extraterrestrial Life in Our Minds and in the Cosmos. And so, Don, as I just told you, it's not often I get to talk to a particle physicist on my show, so I'm starting with you. And my first question really is, how much are NASA scientists and engineers sweating right now?
Well, they have to be sweating an incredible amount. For one thing, it's a very difficult project from a technological point of view, and it's very far away. This whole entire thing will be done in an automated form, and you just have to trust that you did it right.
Trust that you did it right. It is complex. Can you begin, Don, to walk me through the actual landing itself and the complexities involved in nailing it at that 12-degree angle just right?
Well, yes. The difficulty is multi-stage. The first thing is the lander has to leave the spacecraft that went from Earth to Mars. It has to go into the atmosphere at a precise angle. If it goes more steeply than 12 degrees, it'll burn up like a meteor. If it goes more shallow, it'll bounce off the atmosphere. And while it's falling, it's essentially a meteor falling into the Martian atmosphere. The Martian atmosphere is very thin, and that's what makes landing on Mars so very difficult. It's 1% the amount of air that we have on Earth, and that makes it difficult to slow down. Once it gets about halfway down.
Can I hit pause? Let me hit pause on the science for a second because I want to explain it to people. And Miles, let me go to you. We have another box on the screen, and I'm assuming this is Pasadena. Is this the JPL lab? I mean, are these the folks who are steering this thing, for lack of a better word?
Well, you know, at this point, they're just going for the ride, Brooke. As he pointed out, this is an automated thing. You know, the people in that room, they are the riverboat gamblers of science, Brooke. They put their chips on the table. They spend a decade or so working on a mission, and it all comes down to 6.5 minutes. And it's either a great day or you just see them droop and get sad, as they did back in 1998 and 99, Mars Polar Lander. When they didn't get that signal back. Those memories are seared in the collective consciousness at JPL. They've had great moments, and they've had moments of absolute agony and defeat as well.
We want to avoid the agony, and we would like a repeat of the high fives from Curiosity in 2012. And Rachel, for people who are just tuning in and are like, why are they talking about Mars and this InSight?
Lander.
What is the purpose of it all?
So, you know, there's been many missions to Mars before, and just to highlight just how difficult this is, pulling off, you know, either landing a lander or a rover or an orbiter, bringing an orbiter to Mars, more than half of the missions have actually failed. So there's about a 40% chance of success here. So, you know, this is incredibly difficult. Space is hard. Just want to highlight that.
Yeah.
But most missions to Mars have been about studying the atmosphere or the surface. It hasn't really been about getting to the core, literally, of the planet and what makes it up. And so that's what InSight is all about. There's actually a heat probe that's going to dig 16 feet into the planet, which is deeper than any other lander has ever gone before. Usually these landers only go to about an inch below the surface. And so they hope to learn about how much heat is escaping from the planet. And that will give us insight into what the core is actually made of. So it's really to get at the evolution of the planet, what the planet is comprised of, to have us learn a little bit about the evolution of these rocky planets like our own, Earth.
So on that, Don, back over to you so this thing, I want you to continue explaining how this thing, actually, let's listen in just for a second.
On the top on this heat shield, very, very hot. But on the inside of the heat shield, it's maybe only a few degrees above room temperature. So it's a wonderful protective device to keep our lander safe.
All right, so the next thing we're standing by for is
Entry. Getting to the top of the atmosphere and gradually slowing down. Right now, the vehicle's just now beginning to, and very soon, we'll be beginning to feel the atmosphere touching it. Actually, entry is above the atmosphere slightly, so it's really not until half a minute or so after entry before we start really detecting the fact that that atmosphere is slowing us down.
All right, we'll be standing by.
Yes, exciting.
All right, so we're all sort of standing by to stand by. Don, why is this referred to as the 7 minutes of terror? When do these 7 minutes begin?
Well, the 7 minutes start about when the orbiter, the landing module, hits the atmosphere. And the problem is that Mars is far away. It takes about 8 minutes at that particular time right now for a radio signal from Mars to get here. So in the descent phase, which is about 6.5 minutes, suppose something happens 3 minutes in. It'll send a signal to Earth, but that signal won't get to us for 8 minutes, in which case, by the time we get it, it'll all be over. So we have to depend on the engineers to have done their job right.
So it's essentially, on a mega delay, and it's not like anyone sitting in this room, sort of as Miles was alluding to, can do anything about it. They're in it for the ride, because once it comes back down to Earth, it would be too late. Am I following you correctly?
Right. The signal, like you say, it's a long delay. So suppose something happens 3 minutes from landing, and it needs some kind of intervention by the engineer. The signal will be sent from the landing pod to Earth. It'll get here in 8 minutes, but it only has 3 minutes before it hits the ground. So there's no way to make any changes. It just has to work at this point.
All right, Don and Rachel and Miles, do me a favor and all stand by. We're holding our breath. I know, I feel the excitement all the way over here, just to see when InSight lands on Mars. Live pictures, Pasadena, California. We'll be right back.
The parachute will deploy.
All right, you are looking live pictures of the JPL, Jet Propulsion Laboratory, Pasadena, California. We are mere minutes of finding out if this InSight probe will actually land on Mars. Let's listen in.
Radio science reports sudden change in Doppler.
Ground stations are observing signals consistent with parachute deploy.
Marco Alpha, Marco Bravo, maintain lock status.
Telemetry shows parachute deployment. Radar powered on. Heat shield separation commanded.
This is really good news so far.
It's fantastic.
I'm on pins and needles.
Yes.
We have radar activation where the radar is beginning to search for the ground. Once the radar locks on the ground and InSight is about 1 kilometer above the surface, the lander will separate from the back shell and begin terminal descent using its 12 descent engines. Altitude convergence, the radar has locked on the ground.
Yes.
Standing by for lander separation.
Carrier interruption on Marco Alpha and Marco Bravo.
Lander separation commanded. Altitude 600 meters. Gravity turn, altitude 400 meters.
We're getting there.
300 meters. 200 meters. 80 meters. 60 meters. 50 meters, constant velocity. 37 meters. 30 meters. 20 meters. 17 meters, standing by for touchdown. Touchdown confirmed.
That's fantastic.
This never gets old.
No, it doesn't, Rob. Control
what a
room
relief.
just erupted.
Fabulous, fabulous.
Hands with the Marco team
Marcos.
there.
Christine, you did great. Tim Preiser, one of the key designers at Lockheed. Sandy Krasner, what a great
relief.
team. What a great. This is really fabulous.
Fantastic news.
Thank you.
Lots of fist bumping going on in there. What a relief. We've cut over to the camera over in Times Square. Boy, people are weathering the rain to see this.
They can't help.
Oh my goodness, the high fives, the fist bumps, the hugs. Ladies and gentlemen, NASA, they have achieved something pretty extraordinary. The InSight probe has now officially landed on Mars. I can feel the excitement. Dawn, and then Miles, and then Rachel. Dawn, first to you. What do you think of this scene?
I am completely jazzed by this. And first thing I'd like to say as a scientist, I would like to congratulate the technical and scientific staff at NASA and JPL. Great job.
Before the science can begin.
And
Just getting
what's just happened? We know it landed on Mars. Tell me more.
Well, now the next step is to shake out the equipment, deploy the solar panels. Then there are 3 different missions that InSight will do. One is to test the wobble of Mars's rotation to find out something about the core of the Mars. Another one will be to deploy a very sensitive seismograph to look for Mars quakes and when meteors hit Mars to find out more about its interior. And finally, and perhaps the most exciting, is to drill down 16 feet underground to actually take the temperature of the planet. And that'll teach us something about the inner dynamics of Mars, and it'll also tell us how warm it's down there. And you know, not from a science point of view, but from an explorer point of view, if it's warm down there, that makes it more likely that there'll be liquid water. So, I mean, all in all, this is going to be a fascinating scientific project.
So these scientists are salivating over the data to come. But Miles, to you, just again underscore for me the fact that this has been flying since May up toward Mars, and the likelihood of this precise landing. There have been so many failed probes in the past. Why is this such a big deal?
You know, Brooke, this is awfully darn hard. You know, we've already made the point that less than half of these landings succeed at all. You know, 500 or so will certainly get you into the Hall of Fame for baseball, but this is tricky stuff. And you know, it always impresses me as you listen to them. They're so calm and cool and collected. You know, they're sweating bullets underneath, though, but they never reveal it. And then when it happens, they just erupt. I would love every young person in America to absorb this, take this in, and realize that studying science and math and engineering isn't as nerdy as you may think. It could lead you into that room, and it could have you giving high fives for putting something on Mars. That's incredible.
Yep. Hey, nothing nerdy about it. I've been to space camp 3 times. Rachel, we were excited in 2012 with the Curiosity rover, and it's a rover, meaning it will move.
Right.
This obviously stays put
Right, it's a
to
lander.
collect the data. It's a lander. What more are they trying to achieve with the data?
Well, first, what's interesting is where they've landed. And they call it like a relatively boring parking spot on Mars, Elysium Planitia. And it's really close to the equator, just north of the equator. And it's, very flat, not very rocky. They chose that for a reason to minimize, any potential damage, not steep. And it will perform all of its duties right there from that one spot. And also close to the equator, so it'll get a lot of sunlight. It's powered by the solar panels that will soon hopefully deploy. There's a lot of dust that happens when this lander, when the thrusters go off, and so they're waiting for the dust to also settle before they deploy those solar panels. But being close to the equator will guarantee that they got a lot of sunlight. But it's interesting that, they're not choosing some really active spot on Mars. This is as they call it, like a good parking spot.
Okay.
So yeah, but every place on Mars, let's be honest, is pretty interesting. It's damn Mars. But also the fact that they just pulled this off, you also have to remember that this was a nearly $1 billion mission, 10 years in the making. So a ton of money on the line. There's watch parties, viewing parties all over the world happening right now. So there was a lot of pressure on NASA to pull this off, and the fact that they just did it so beautifully with the odds against them really it speaks to the power of those scientists and engineers. It's absolutely incredible.
It's amazing. It's amazing. Rachel, thank you for your excitement. And Miles and Don Lincoln, thank you all so very much. And again, a huge, huge, huge congratulations to NASA.
They're now flying on.
Thank
They're
you.
now taking pictures back toward Mars. Hopefully